This is a homework problem from section 3.1. I had a couple people stop by my office for questions similar to this, and I got a couple of emails. So this could have been the email that I haven't responded to yet. So I decided that I had enough questions about this that I was going to go ahead and do one of these in class. So the directions say to put this in standard or vertex form. That's what the directions say for this. And then we're identifying the vertex. I'm not sure if you're graphing it or not, but we've got to get it into standard or vertex form. And that's the difficult part, is getting it into that. So what we have to do here is we have to factor out a 32. And that's where students get confused. So I have f of x, and I am pulling out a 32, and I have x squared minus 8x. And I've got to factor a 32 out of that negative 8. And students get confused. They're not sure what to do about that. Like, what do I do about this negative 8? So all you need to do here is you need to put the 32 over the 8. Okay, so when I factor a 32 out of that, my 32x squared minus 8x, what that becomes is x squared minus 8 over 32x. And I know we don't like that because it's fractions. But that's okay. That's part of our mathematical life, is fractions. Then my plus 3 over 2 is on the outside, so I'm not dealing with that. This actually works out very nicely. So I just want to show you that if I multiply 32 times negative 8 over 32, I get negative 8, and that's what we want. Now, can that negative 8 over 32 be simplified? Yes, it can be simplified. What is negative 8 over 32 simplified to? Negative 1, I keep hearing it, negative 1/4, yes. Okay, so I can change this negative 8 over 32x to negative 1/4x. Okay? So now that I've done that, it's a little bit easier to think about. So my next step in completing the square is taking half. I'm about to sneeze, I'm sorry. Taking half. Okay then, I'm sure it'll come back. We've got to take half of negative 4th. So we're going to do 1/2 times negative 1/4. And so I get negative 1/8. What's my next step? Once I have half of my b value, what do? Square it. Okay? And we get I was going to say very large fractions, but actually what we're getting here is a very small fraction. Okay? We're dealing with a very large denominator, and at that point, we may think that we've made a mistake. But we haven't. We haven't. Now, remember, I am not just adding 1 over 64. I'm adding 1 over 64 times what? Times 32. Okay? 1 over 64 times 32 simplifies to 1/2. Okay? So because I ended up adding 1/2 right here, what do I need to do out here? I'm not adding 1/2. Subtracting 1/2. I've got to do the opposite. So I added 1/2 inside. So I've got to do the opposite on the outside. So I am going to subtract 1/2. Okay? Now I'm in pretty good shape. Now I'm in good shape. So I have f of x equals 32. I can factor this. (3 over 2 minus 1/2 is 1. So can I, at this point, identify my vertex, its direction? Can I do that? I can. Okay? Does that help? So I just knocked out like 4 emails right there. Go me, right? I'll still respond to emails, don't worry. Okay. Now we're going to take a stroll back to 4th and 5th grade. I'm going to give you 1 minute to divide. You are dividing using long division from 4th and 5th grade. Is it coming back? Long division? Anybody remember long division? A little bit? Okay. So if I'm solving this using long division, what I'm going to do is I'm going to say 7 goes into 7 how many times? 1 time. Now I can also say 7 times what gives me 7? Okay? 7 times what gives me 7? Now I'm going to put that 1 right on top of the 7 because it's a place value thing. I'm going into the 7. I'm dividing into it. Okay? Then I do 1 times 7 is 7. Then, this is where people make their mistakes when we transfer this to algebra. I subtract right here. Okay? I subtract. 7 minus 7 is 0. What do I do next? Bring down the 3. How many times does 7 go into 3? 0. So I have to write that place value there. That's going to be important too. So remember that place value. Nothing goes into that, so I bring down my 4. How many times does 7 go into 34? 4 times. 4 times 7 is 28. Again, I subtract. And I have a remainder of 6. So I can write this as 104 remainder of 6. But another way I can write it is 104 6 over what? Not over 1, 7. It's 6 over what I'm dividing by. 6 over what I'm dividing by. Okay, so it's 104 and 6/7. Now, how would I check this? What would I do if I was going to check it? What? Divide it again to see if I was right? Is that what you said? Oh, do it on my calculator. Yeah, that's true. What's the inverse of division? Multiplication. So what could I multiply together to check it? Okay, so I'm going to do 104 times what? 7. What do I do with that 6? I add it on. Good. I add it on. So it's 104 times 7 plus 6. So I want you to remember these principles as we apply it to long division. Okay? So I want you to remember these principles as I apply it to long division. Okay? So I am going to use that same process to divide polynomials. So I am going to put my x plus 1 inside my box. I'm sorry, outside my box. I should not, the x plus 1 is what I'm dividing by, so it's got to be on the outside. The x squared plus 3x plus 5 goes on the inside. Okay? X squared plus 3x plus 5 divided by x plus 1. So, I am going to ask myself, x times what gives me x squared? X times what gives me x squared? X. Okay? So I'm going to write that x above my 3x. It's a place value thing. Just like with the problem before, I wrote my 1 over my hundreds and the 0 over my tens. I'm going to write my x to the first over my linear term, which is my 3x to the first. Okay? Now I'm going to multiply. X times 1 is 1x. X times x is x squared. Now, this is where students make mistakes, right here. What are we doing here? Subtracting. That's where students make mistakes. They forget that we are subtracting. They forget that we are subtracting. Okay? So don't forget that you're subtracting. My x squared and my negative x squared cancel, which is what we want to happen. 3x minus 1x is 2x plus 5. Okay? So I ask myself again, x times what is going to give me 2x? 2. 2 times 1 is 2. 2 times x is 2x. And I am doing what? Subtracting. Okay? So I am left with 3. So, my answer to this division problem is x plus 2, remainder 3. But I can write that as a fraction. So I have x plus 2 plus 3 over what I am dividing by. So what's my denominator? X plus 1. Now, let's talk a little bit about what it means to get a remainder. Okay? In my first problem, my 4th or 5th grade division problem, if I had not gotten a remainder, if I had gotten 0, what would that have meant? Okay? That it goes into that number how? Evenly. Okay? I get a whole number, I get an integer, it goes in evenly. The same is true here. I didn't get a 0. So what that means is my x plus 1 doesn't go into it evenly. Okay? It doesn't go into x squared plus 3x plus 5. Another way that we're going to say it this semester is x plus 1 is not a factor of x squared plus 3x plus 5. It's not a factor. Okay? So because I got a remainder, x plus 1 is not a factor. X plus 1 is not a factor. Okay? The other thing that I could do is I could write this, I could multiply x plus 1, I could multiply that times x plus 2, and then add my remainder to it, and I would go back and get my original problem. Now that's a lot of algebra and a lot of computation, and it really doesn't get us anywhere, but I want you to see the relationship. It's important that you're able to kind of identify what's going on here. The reason that this is important is because this tells us that x plus 1 is not a factor. X plus 1 is not a factor. If I multiply this, x original problem. Okay? Okay. Now, let's do another one. Let's do another one. I have 6x to the third minus 19x squared plus 16x minus 4. I am dividing that by x minus 2. So, my 6x to the third minus 19x squared plus 16x minus 4 goes inside my box, and I am dividing by x minus 2. Okay? So what I am ultimately trying to figure out is x minus 2 a factor? Now, look closely at 6x to the third minus 19x squared plus 16x minus 4. It has 4 terms, so if we were factoring that, we would try to factor it by grouping. Would we be able to factor this by grouping? Could we factor this by grouping? Okay, what goes into the first 2 terms? X squared. Okay, then I would get 6x minus 19. What goes into the second 2 terms? 4. Am I going to get 6x minus 19 when I factor out the second 2 terms? No, so it's not going to work. So division is what allows us to find factors when these aren't factorable, because this is not factorable. So we have to use division to try and find it out. So here, I'm going to ask myself, x times what gives me 6x to the third? 6x squared. Okay, so now I'm going to say 6x squared times negative 2. So that's going to give me negative 12x squared. 6x squared times x gives me 6x to the third. But remember, what am I doing? I'm subtracting. Don't forget that. We are subtracting. Okay, so I have minus. Okay, and since I've got a negative with the 12, that becomes a plus. This cancels, which is what we want it to do. Then I'm left with negative 7x squared plus 16x. So I just brought that 16x down. X times what gives me negative 7x squared? Negative 7x. Do you see how I wrote that right on top of my x term? And the 6x squared is written right on top of my x squared term. Okay, look at this right here, just to make sure you see it. X squared, xx. Okay, now I'm going to multiply. Negative 7x times negative 2 is 14x. Negative 7x times x is negative 7x squared. I am subtracting, so my negative 7x squared becomes positive. My positive 14x becomes negative. Okay, 16x minus 14x. Okay, and now I bring down a 4. X times what gives me 2x? 2. 2 times negative 2 is negative 4. 2 times x is 2x. I am subtracting, and what do I get? 0. Okay, I get a remainder of 0. So what that tells me is that x minus 2 is a factor. X minus 2 is a factor. And if I were to multiply x minus 2 times what I got, 6x squared minus 7x plus 2, if I multiplied those two together, I would get what I started with. Now, ultimately, what we are going to do with division is find all of my factors. If I find all of my factors, what else have I found? My x-intercepts. So if I have my factors, I set those equal to 0 and I get my solutions. Okay, so that's what we're doing here. Now, 6x squared minus 7x plus 2 can be factored. Okay, so let's remind you how to factor this. And if you don't know how to factor this, we have got to talk. You've got to come and see me. Okay? What's 6 times 2? 12. So my product here is 12. What's my sum? Negative 7. So I am looking for two numbers multiplied together give me 12, added together give me negative 7. I don't know why I keep saying negative 6.
3 and 4.
What kind of 3 and 4? Negative 3 and negative 4. Okay, so I'm going to have 6x squared minus 4x minus 3x plus 2. What comes out of both of those? What comes out of both? 2x. So then I'm left with 3x minus 2. Yes, you are correct. Minus 2. Whoa. 3x minus 2. What comes out of the next one? Ooh. Negative 1. I did not do well here, did I? Okay. Sorry about that. Okay. X minus 2. I have 2x minus 1. 3x minus 2. Is that what you got when you factored it? Now, what I have right here are my factors. That's what I have right here are my factors. What I can get from my factors are what? What are those right there? X minus 2 equals 0, x equals 2. 2x minus 1 equals 0, x equals 1/2. What are those? They're x-intercepts. You also might hear them called solutions, zeros, and x-intercepts. That is our goal. What we're learning today, the whole goal of what we're learning today is to get to our solutions. That's why we have to divide, is so that we can get to our solutions. Okay? So, I am going to talk to you about synthetic division, because synthetic division makes it much easier. Now, the division algorithm, what that tells me, and we talked a little bit about that, what that tells me is this right here is what I started with. Okay, this is my original. That's my original right there. Okay, this right here is my answer. This is what I'm dividing by. Okay, and this is my remainder. Now, I'm going to give you a second to write that down. Okay, so our very first problem, we had x squared plus 3x plus 5 divided by x plus 1. Our answer to that was x plus 2, and then we had a remainder of 3. That is what this is telling me right here. My original polynomial is equal to what I divided by, which is my x plus 1, times my answer plus my remainder. Okay, now I need to go back a couple of slides because I want to show you something because I made a mistake. Okay, I still see people writing it. So, okay, here it is. So this should be this right here. I should not have put that over. Now my answer is fine. X plus 3 over x plus 1. But my remainder should have standed alone when I was doing this right here. Okay, so I'm sorry about that. The correct way to write it would be this right here. So you might want to go ahead and take a picture and make sure you've got that written down. Because when you are writing your remainder right here, do not put it over what you're dividing by in this situation right here. Because what you're doing right here is you're trying to multiply it together to get back to the original. You write it over over what you're dividing by when you're giving an answer. So let's go back to our 4th grade problem. Good? Okay, so if we go back to our 4th grade problem, is that our 4th grade problem? Okay, do you see how when I check it, I do 104 times 7 plus 6? I don't do 104 times 7 plus 6 over 7. 104 and 6 over 7, that's my answer. That's what I got when I divided. What I'm doing here is I'm checking to make sure I get back to my original problem. That's a great question, though, and I messed that up when I did it. Okay, now the bulk of what we want to talk about today is synthetic division. Okay, and I think students do better when they are not trying to look at a book definition of synthetic division. What I want you to notice, and what I want you to really think about in this situation, is I want you to realize x minus k, that's my factor. And when we are doing long division, we are dividing by a factor. Okay? What I put outside my box is a factor. The difference when I do synthetic division, what I put inside my box is a solution. Okay? So if x minus 3 is a factor, what is a solution associated with that? It's not negative 3, positive 3. Okay? So the way I go from a factor to a solution is I set it equal to 0. Okay, so I have x minus 3 equals 0. That's my factor. X equals 3 is my solution. So that is an important thing to distinguish between, is your factor and your solution. Okay? Now, we just did this problem. Okay, so we just did this division. What I want to do now is I want to do it using synthetic division so that you can see how synthetic division works. Now, this is my factor. So what is my solution associated with that factor? Positive 2. So I am going to put positive 2 inside my box. Then I am going to write down only my coefficients. So I have 6, negative 19, 16, and negative 4. 6, negative 19, 16, and negative 4. Okay. I am going to bring down that 6. That's the first thing I'm going to do is bring down that 6. So I'm going to bring it straight down. Then I am going to multiply this 6 times 2. So I multiply by that number right there. What is 6 times 2? Okay. Now I combine these. I'm not subtracting. I'm adding. Negative 19 and positive 12. What is that? It's negative 7. Okay? Now, I take that negative 7, multiply by 2. What's negative 7 times positive 2? Okay, that's negative 14. 16 and negative 14 is positive 2. I take 2, I multiply it times 2, and what do I get? 4. Now, let's talk about what all these different things are. This right here is a remainder. That is our goal. When we get 0 as a remainder, that means this is a solution, and it means this is a factor. Okay? Our ultimate goal is to be able to find all of our factors when a polynomial can't be divided. Okay, so when I get a remainder of 0, that means I've done what I needed to do. Okay? This is my constant. That means it's not going to have an x or an x squared with it. This is my coefficient for x. This is my coefficient for x squared. Okay? So I can write x minus 2 times x squared plus x plus, oh no, sorry. Okay, what are my coefficients? So what do I have with this x squared? What goes in front of it? So I've got 6x squared minus 7x plus 2. And that is exactly the same thing we got when we did it the first time. And what did it factor to? So we've already got the factors to that. What did it factor to? I don't have it in front of me. Can you? Oh, here it is. 2x minus 1 and 3x minus 2. Okay. So synthetic division is an easier process to long division. We still get the same answers, but it's much easier to use. Okay? Can I go to the next screen? Okay. We've already done this one. Okay? We've already divided x squared plus 3x plus 5 by x plus 1. We've already done that division. Okay? We know it doesn't work and we have a remainder. But I want to show you what it looks like using synthetic division. If this is my factor, what do I put in my box? Good, negative 1. Then I have a coefficient of 1. What's the next coefficient I have? And then I have, good. Okay? I bring my 1 down. What do I multiply that 1 by? 1. Negative 1. Okay, 1 times negative 1 is negative 1. What is 3 and negative 1? 2. Now I multiply 2 times negative 1. What do I get? Negative 2. What's 5 and negative 2? 3. 3 is my remainder. Is that the remainder I got when I did long division? Okay. 2 is my constant. 1 is the coefficient that goes with my x. So I get x plus 2 with a remainder of 3. So that tells me that x plus 1 is not a factor. Okay? Not a factor. Not a solution. Not a factor and not a solution. Okay? Okay. Can I go to the next screen? Okay. This has 5 terms. 5 terms. We cannot factor something with 5 terms using the grouping method. We have to use synthetic division. Okay? So I am telling you, and depending on how your test is going, you're probably going to be told what some of the factors are. I'm telling you that x minus 2 and x plus 3 are factors. Okay? So we're going to find the rest of the factors, and once we have all the factors, what can we find? The x-intercepts. Okay? So, I'm going to start with x minus 2. If x minus 2 is a factor, what is my solution? Positive 2. So that's what goes in the box. Okay, now I'm going to write down my coefficients. I have positive 2, positive 7, negative 4, negative 27, and negative 18. Okay, so I am going to bring my 2 straight down. What do I multiply that 2 by?
2.
Good. What's 2 times 2?
4.
Good. Okay. Then I have 7 and 4. I add those together. What do I get? Good. What do I multiply 11 by?
2.
Okay. 11 times 2 is 22. Negative 4 and 22, what does that give me? 18. What is 2 times 18? 36. Okay, negative 27 plus 36 gives me what? Okay, what am I going to multiply 9 by? What do I get? 9 times 2 is?
18.
Okay, and I get a?
0.
Good. So I've gotten a remainder of 0. The remainder of 0 confirms that 2 is a solution and x minus 2 is a factor. It confirms that. Now my hope is that now I can factor this. So I'm just starting with my 2, and I am writing down the coefficients. Okay? 9 is my constant, and I work up from there. Okay. Can that be factored? Can 2x to the third plus 11x squared plus 18x plus 9 be factored? Okay? What comes out of the first 2? X squared. X squared comes out of the first 2, and I'm left with 2x plus 11. What comes out of the second 2? 9, and I'm left with 2x plus 1. So does it factor? No. That means I have to use synthetic division again. Okay, and that's okay because we were told what another factor was. So if x plus 3 is a factor, what's the solution associated with it? Good. Okay, so I have negative 3. So then I'm going to have 2, 11, 18, and 9. I bring the 2 straight down. What do I multiply the 2 by? Okay, 2 times a negative 3 is what? Okay, what's 11 and negative 6? Okay, I'm going to multiply the 5 times negative 3. 5 times negative 3 is negative 15. What's 18 and negative 15? I take my 3 and I multiply it times. What do I get? Negative 9. And I get a remainder of 0. Okay? So now I have, I'm going to do this in green so we can keep it all straight. I have x minus 2 from right here. What's my factor here?
X minus 3.
It's not x minus 3, x plus 3. Okay, then I have a trinomial here. 2x squared plus 5x plus 3. Okay, that can be factored. Okay, 2x squared plus 5x plus 3 can be factored. If it could not be factored, what could you use? If it could not be factored, what could you use? Say that again. The quadratic formula, yes. And on your quiz, on number 1, you've got to use your quadratic formula. Okay? Now I'm going to go ahead and factor this just so we can remember how to factor. Okay? So I'm going to do it kind of over here. 2x squared plus 5x plus 3. What's my product? 6. My product I'm looking for, I take 2 and I multiply it times 3. My product is 6. What's my sum? 5. What two numbers multiplied together give me 6? 2 and 3. 2x squared plus 2x plus 3x plus 3. So I take a 2x out. Then I take a 3 out. So this factors to 2x plus 3 and x plus 1. Okay? So, I have x minus 2 times x plus 3 times 2x plus 3 times x plus 1. Those are my factors. So my solutions, negative 3 over 2, those are my solutions. So you've got to understand the relationship between factors and solutions. Factors and solutions. To get a solution, you set a factor equal to 0. Okay. There are some that you cannot use synthetic division. So this one right here, we are going to use long division. And there is all sorts of stuff messed up about this problem. Okay? What is the first issue that you see with this problem? Your exponents are not in decreasing value. Okay? So before I can do anything, I have got to deal with my exponents and make sure they are in decreasing value. Okay? So, what is my highest exponent? 2x to the fourth. So I am going to put 2x to the fourth first. And I am putting all this inside my box. 2x to the fourth is taken care of. What's next? 4x to the third? Good. What's next? Good. What's next? And what's next? Good. Okay, so that's the first issue that I got to deal with. Okay, look at what I'm dividing by. Is that in order? No, so I got to put that in order. So, the reason that I cannot use synthetic division here, whoops, I put a square root sign. Do you guys see that? Okay, so now I've got x squared plus 2x minus 3. Okay? Now, I don't have enough room, so I'm going to go to the next screen. And you need to make sure I wrote down the same thing on the next screen, okay? Do you have it written down on your paper? No? Okay. So, do I have that written down correctly? Okay. We have to do long division here because what I'm dividing by is raised to the second power. That's why we have to use long division. We can't use synthetic division here. We have to use long division. So, what I'm going to do first is I'm going to follow that same process. I'm going to say x squared times what gives me 2x to the fourth.
Isn't it a negative 5?
Yeah.
Okay, thank you. Thank you, thank you. Whew. Man, that would have given us headaches later. Okay, is it written down correctly now? Okay, good. Thank you. Okay, x squared times what gives me 2x to the fourth? 2x squared. Now, where do I write that? What do I write that above? Yes. Okay, it's like a place value. So I am going to write 2x squared right above my negative 5x squared. Okay? Now, I'm going to multiply. 2x squared times minus 3x, or just minus 3, is going to give me negative 6x squared. 2x squared times 2x is going to give me 4x to the third. 2x squared times x squared is going to give me 2x to the fourth. And what are we doing? Subtracting. So I've got to make all of this its opposite. Okay? And look right there. What happened that's a little bit weird? Say that again? There was a double cancel. So we don't know exactly what's going to happen with that, but that's not what happens in all the different problems. So something's going to be a little bit different here. Okay? So now, yes?
Does it matter, like, which one you multiply by first? Like, you started from negative?
It doesn't matter. So if you wanted to start with 2x squared times x squared, you'd be fine. You'd be fine. Okay? So I'm going to go ahead and do negative 5x squared plus 6x squared. So when I do that, I'm left with 1x squared. Now, when I say to myself, x squared times what gives me 1x squared, what do I get? Just 1. Okay? So I am going to put that 1 over the negative 2. So I bring down this 3x, and so what's going to go over that 3x? A 0. And because of that 0x as a placeholder, I can go ahead and bring down this negative 2. Okay? So now, when I multiply x squared plus 2x minus 3 times 1, I'm able to just write it right underneath. So I have x squared, so 1 times x squared, 1 times 2x, 1 times negative 3. What am I doing? Subtracting. Okay? So once I combine all these, I'm left with 1x? 1x plus 1. So my remainder here is x plus 1. So when I've divided all this, my final answer is 2x squared plus 1. Then I've got my remainder, and what do I put my remainder over? Good. Okay, so this is my final answer. So I don't have any factors. I'm not any closer to what I need. All I've done is I've divided this. Okay? You're not going to see see a lot of that in this class, but I did want to expose you to it because you will see it on the homework. Okay, you don't really see it on your quiz or your test, but you do see it on your homework. Okay, now here's another one, and we're going to do synthetic division here. What do you notice about this? I've got x to the third minus 1 divided by x minus 1. What do you notice about this? Okay, it's two binomials. Okay, look at the x to the third minus 1. What are we missing? I'm missing my x squared, and what else? And my x. So I need to think of this. As x to the third plus 0x squared plus 0x minus 1. I have to account for those coefficients even though they're not written down. And when they're not written down, I have to put a 0 there. Okay? So I can use synthetic division. If this is my factor, what goes in my box? Positive 1. Then I have a coefficient of 1, 0, 0, and negative 1. Okay? I've got a whole bunch of 1s here. I am going to bring this 1 straight down. Okay? 1 times 1 is 1. What's 0 plus 1? 1 times 1 is 0 plus 1. 1 times 1 is negative 1 plus 1.
0.
Okay, so what this means is this is my remainder. Since I got a remainder of 0, what does that tell me about x minus 1? It's a factor. So this is a factor. This is a solution. Okay? Then I have x squared plus 1x plus 1. And if I multiplied this times x minus 1, I would get my original problem, which is x to the third minus 1. Now, this cannot be factored. This can't be factored right here. So what do you have to do? I'm sorry? I could divide it again, but I also have a technique for quadratics. What's the technique for quadratics? Quadratic formula. So here, what I would do is a quadratic formula. To solve that, I would use the quadratic formula. Okay? Okay. Now, I'm going to give you 2 minutes. I'm going to give you 3 minutes, actually, to do this right here. What's a possible mistake that students make? What do they forget? Oh, whoops, I didn't tell you what you factored by. My fault. You guys could have yelled at me. Okay, sorry. -3 is the solution. -3 is the solution. So start with -3. Put that in there. When you're setting this up, what do you have to do, though? What do you have to do for your x squared?
-1.
I don't have a -1 for x squared. 0. So I've got 1, 0, -19, and -30. Is that better now that you know -3 is the solution? A big mistake that students make is they forget to deal with this 0x squared. Okay, that's a huge mistake. It happens all the time on your test. It's when students forget to address that coefficient because we skipped a degree. You have to account for that, and that's why that 0 is there. So be sure you are accounting for that. Okay. Now, what I'm going to do is I'm going to bring this 1 down. So I've got -3 times 1. What is that? Good. 0 plus -3 is -3. -3 times -3 is +9. -19 plus +9. Oh, it is negative. Whoops, I almost missed that. -3 times -10. What did I get? A remainder of 0, which is what I wanted. If -3 is a solution, what's its factor?
X minus 3. X plus 3.
X plus 3 is the factor. Then I've got x squared minus 3x minus 10. I am able to factor that. I'm looking for 2 numbers that give me -10. When I multiply and add it together, give me -3. Good, -5, +2. These are my factors. My solutions are here. Now, I want you to look at this number right here, -30. I want you to look at that number, -30. So we have a theorem that tells us when we have to start trying to figure out what to divide by, we look at factors of that constant. Okay? There's a theorem that tells us that. Now, -30 and the next one that we do have a lot of factors. I mean, we've got ±1, we've got ±2, ±3, ±5, ±6. We have a whole bunch of factors. So when you have that many factors, I will often give you the number to start with. And I will probably give it to you on your test. Now, I want you to look right here. What is this right here? Or actually, this is the graph to what we just did. Now, a lot of times I will go and I will graph it on Desmos so that I can figure out what my first solution will be. Now, I told you to use -3, correct? There's -3 right there. So don't hesitate to graph it first. you can identify where to start. Now remember, you won't have Desmos on your test, so I will give you those on your test. I'll give you something to start with, or I'll just give you a number that's so low you don't have very many to choose from. Okay? Now, I want to do one more, and then I've got a problem on the board I'm going to do. Okay. So here I've got 5 variables. Not 5 variables, 5 terms. We can't factor 5 terms. And negative 24 has a whole bunch of factors. So if I take a peek at this graph, okay, this is a fraction, so I don't want to deal with that fraction. This is a fraction, so I don't want to deal with that fraction. But right here, I've got 3 and I've got 4. So I could start with either 3 or 4. It doesn't matter which one I start with. I could start with either one. Okay? So I'm going to start with 3. So I'm going to put 3 in my box. Then I have x to the 4th, x to the 3rd, x squared, x, and then I have my constant. And it seems big, but this is so much better than doing long division. So much better, I promise. Okay, so I'm going to bring that 1 straight down. 3 times 1 is 3. Negative 7 plus 3 gives me negative 4. 3 times negative 4 is negative 12. What's 10 times negative 12? I'm sorry, 10 plus negative 12. Negative 2. 3 and negative 2 gives me negative 6. 14 plus negative 6. 8. Whoa. Okay. 3 times 8 is, and I get 0. Okay, so I get 0. That tells me I did it right. So, if 3 is a solution, x minus 3 is a factor. Okay? Constant x, x squared, x to the 3rd. So I'm going to start with x to the 3rd minus 4x squared minus 2x plus 8. And I can factor that. I can factor that by grouping. Okay? So I have x to the 3rd minus 4x squared minus 2x plus 8. What comes out of the first 2? Good. X squared. Then I'm left with x minus 4. What comes out of the second 2? Okay. So I have x squared minus 2 and x minus 4. Now, when I start dealing with this, because that x squared minus 2, that can't be factored any further. It's not a difference of perfect squares, so I can't factor it any further. X minus 3 gives me a solution of 3. X minus 4 gives me a solution of 4. But I might be stuck at x squared minus 2. Okay? But if I set x squared minus 2 equal to 0, I get x squared equals 2. So what does x equal? Plus or minus the square root of 2. So how many solutions do I have? 4. Because I've got positive square root of 2 and I have negative square root of 2. Positive square root of 2 and I have negative square root of 2. Okay, so I have found all my solutions. And here is my graph. So here is my 3, here's my 4, here's my positive square root of 2, and here's my negative square root of 2. Okay, I'm not done. I've still got 5 minutes, so don't pack up. Okay? So, At 1 p.m., I'll be in room 221. I'm pretty sure it's 221. Okay? I'll be in that room, and it's for you to work in small groups on your quiz. And I recommend that you look at that quiz soon, especially that last page. So I'll be there to tell you whether or not you're headed in the right direction. That's what I'm doing. If you have emails out to me, I will get those taken care of today. Now I have time, so I want to do this particular problem right here. Okay? I have f of x equals x squared plus 6x. Okay? I'm trying to get this into the vertex standard, so it's just like what we did at the beginning of the class. Okay? It's just like that one that we had that 32 in front of that x squared.